Today, adding something not completely new, not completely different, but a little bit. What it is it's going to show us how to check our solutions to equations. So we got an equation, we got some answers, we need to check to see which one's correct. So there's a couple ways you could do that. One way would be you could solve the equation. Sometimes that's going to be a little bit more complicated than we can do. The other way with problems like these, it's asking which value from the set makes t minus 31 equals 127 true. Well, what we can do is we can take the possible solutions they give us and plug them in. That's what a solution is. A solution is what makes an equation true. So in this case, just kind of go in order. 158 is the first one, so we put 158 in for t, and we got minus 31. 158 minus 31 that gives me 127. That one's true, right? That's the answer. With any of the others, 127 minus 31, that'll be 96. 96 minus 31, that's 65. 31 minus 31 is 0. So we're looking for the one that gives us exactly like the equation. That makes sense? Any questions on that? So sometimes they get a little more complicated. Is that a whole lot more complicated? No, it still works the exact same way. We're still plugging in for the letter. So we would do the parentheses first. So I'm going to put 6 in for n. So I'd have 6 minus 4 exponent of 3. So once you plug it in, we do the parentheses first. So 6 minus 4 gives us 2. We still have to the third power with that. 2 to the third power, 8. We need 216. Obviously, that's not the right answer then. So we go to the next one. We put 10 in. 10 minus 4 to the third power. 10 minus 4 is 6. 6 to the third power, 6 times 6 is 36. Times 6 again is 216. If we kept plugging these in, we would get answers that would be much higher. We'd have 64 to the third power. I can't do that one in my head, so I'm not going to bother doing that one. That's going to be way too high. All right, same idea if we plug in the 76. Do we see how this works? This isn't crazy difficult, is it? We've done substitution already some this year. This is basically substitution. You're subbing in a number for the variable. So another one that's a little more complicated. It's asking which value from the set, again, is making the equation true. The equation has 2 variables. You see we got x, we got a y. The good news is when it's got 2 variables, it'll usually tell you what one of them is. Still works exact same way then. We're plugging in for the value they did not give us, in this case the x. So I got 2 to the 5th power plus, I'm put in 10 first, minus 2, we put 6 in for y because that's what it said. And it's going to need to equal 26. So we can leave off that part and see what it's going to equal. So 2 to the 5th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Plus 10, 6 plus 7 is 13, 13 times 2 is 26. 32 plus 10 is 42. 42 minus 26 is 16. So that doesn't work. Sometimes you can tell a little bit what number to try, though. How much higher do we need this number to be? 10. We got 16, we need 26. Well, that was with 10 for the x value, so we should probably try 20, right? If we were going in order, that'd be the next one anyhow, but we'll put in the 20. So, whoops, didn't mean to write that. We got 2 to the 5th power plus 20 minus all that. So 2 to the 5th power, we already said, is 32, plus 20, and then we said that was minus 26. The good part is, like, stuff like that, 2 to the 5th power, the parentheses we had here, you're reusing it over and over, so you don't have to recalculate it each time. So 32 plus 20 is 52. 52 minus 26 is 26. Okay? Any questions? Do fractions make a difference? No, still works the same way. All right, we're going to substitute for the x. So I got 3/4 times x. My first x value is 1/8. This is multiplying, so when you multiply, you do it straight across. We got 3 over 32. That is not 3/5. So we just keep going. 3/4 times 3/8. 9 over 32. That's not working. So 3/4 times 4/5. That's 12 over 20. 12 over 20 can be simplified, though. What goes into each of those? 4. So 12 divided by 4 is 3. 20 divided by 4 is 5. And that's what we needed. So that means 4/5 is our correct answer. All right, you just got to follow your rules with fractions if it's got fractions. If we can have one of these with fractions, what else could we have it with then? Decimals. So I'm going to show you the other way for the decimal one, okay? That's a fairly easy equation, right? That's just a one-step equation. So how do we solve a one-step equation? Opposite. So your options are, you can do that substitution like we've been doing on the other ones, where you just plug in the number for the variable. If it's more complex, obviously that's what you want to do. For a simple, like, one-step equation, we're just going to do the opposite. It's x minus 2.5, so we go plus 2.5 to each side. Cancels out over there. So we got x equals. My decimals are lined up, so I just add 0.1 plus the 0.5 is 0.6. 5 and 2 is 7. We got the 4. So we got 47.6. Extra zeros at the end of decimals doesn't change anything. So there's our answer. You see how this is easier if it's a one-step equation? If it's a one-step equation, I would just solve it. If it's got a lot more steps or a lot more complicated, like the ones with the exponents and stuff like that, then you want to substitute and plug them in. Okay? Any questions on that one? No, so really, that was it. I said it's nothing that's completely new, was it? The last one we solved a one-step equation. Before that, we did some substitution by plugging in numbers. Each of those are things that we've done before. So